Good morning. Today we are working on CO21. CO21 is I can identify prime and composite numbers. So in order to be able to identify prime and composite, we need to know the definition of a prime number and a composite number. So thank you to my friends who have their attention up here. We're not being silly and goofy anymore. We are focused. What happened on the last objective is people were not focused. They were not writing what I wrote on the board. They did not write it in their binders. And a lot of people got a lot wrong. So I need us to be focused and writing in our binders and following along. A prime number is a number whose factors are itself and 1. 1 is not a prime factor because it only has one factor. So in order to be a prime number, we can't divide it down anymore. So if we look at the first few numbers, 1 cannot be prime because there's only one factor, 1. 1 times 1 is 1. 2 is 2 a prime number? 2 times 1 is 2. Can I do any other multiplication factor buddies to get to 2? No. What about 3? Would 3 be a prime number? What 2 numbers can I multiply together to get to 3? Layla? Kelly? 1 times 3. There's nothing else I can multiply to get to 3. So 3 is a prime number. What about 4? Okay, and why is 4 not a prime? Was that you that just answered that? Oh, that was Melanie. Melanie.
Because you can do 1 and 4, or you can do 2 and 3.
With 2 and 3, it's just itself times 1. But with 4, we can have 1 times 4 or 2 times 2. There's another way to get to 4, so that is not prime. If there's another way to get to the number, multiplying together, it is not prime. Ava.
And also, well, Mr. Schultz taught me this, but 2 is the only even prime number.
We haven't gotten to that yet, but you are absolutely correct, because of course Mr. Schultz is so smart. 2 is the only even number. Remember, our even numbers end with a 0, a 2, a 4, a 6, or an 8. For those even numbers, 2 is the only one that's a prime, because all other even numbers we can divide by 2. We can multiply something by 2 to get to it. So 2 is the only even number. But that does not mean that all odd numbers are prime. Because if we look at 9, 9 is not a prime because we could do 3 times 3. So the only even number is 2. And there are some odd numbers, but not all odd numbers. If it is not a prime number, it is a composite number. A composite number is a number with more than 2 factors. So when we looked at 4, we had 1 and 4 and 2 are factors. So it's more than 2 factors. Or we could say a number that is not prime. So if it's not prime, it is composite. Since you won't be able to use your calculator on this part of the test, the best way to determine if a number is prime or composite, is to use those divisibility rules from that last objective. That's why I was going over and over and over it last week, to do the work because we're using it now. What we did last week, we need to know those rules. Can I divide it by 2? Can I divide it by 3? Can I divide it by 4? If you can divide it by those, then it's the best advice I can give is to not assume anything. Numbers that look prime may very well end up being composite. Again, check by referring to the CO20 divisibility rules. So if we have a big number like 117, I know 117, it looks to me like that would be prime, but it's not. We know it's not divisible by 2 because that 7 is an odd number. If I add 1 plus 7, that's 9. 9 is divisible by 3. 9 is divisible by 9. Right? So it has more factors than just 1 and 17. So let me scroll up to show you how we're going to answer this. Determine if each number is prime or composite. If composite, explain how you know. I know 75 is composite. How did I know that right away? Callie?
Because you can multiply it 5.
I can divide by 5. I don't have to know what it is, but I know it's divisible by 5 because it ends in a 5. So that's all that you have to, you don't have to do all the math. You could say, oh, 10 ends in a 5. It's not a prime number. It's divisible by 5. 41, do you think that's prime or composite? If we're not sure, do those divisibility rules like we were supposed to do on the last objective. Is it divisible by 2? Nope, it's not an even number. Is it divisible by 3? 4 plus 1 is 5. Nope. Is it divisible by 4? Nope, it's not divisible by 2. Is it divisible by 5? Nope, doesn't end in a 5 or a 1. Is it divisible by 6? Nope, it's not divisible by 2 or 3. Is it divisible by 9? Nope, 5 is not divisible by 9. Is it divisible by 10? Nope, it doesn't end in a 0. I can't divide it by any of those, so it is prime. This right here is how you know. It's not divisible by any of the numbers. Madison.
For composite, can we write CO?
For composite, I guess you could write COMP. 36. Ava?
It is,
How do we know it's composite, Ava?
yeah, it's composite because you can multiply 6 times 6.
So I can divide by 6. Yep.
Question.
Yes.
Let's say like multiply, but then you take
Yes. So you could say, you could multiply 6 times 6. I'm wanting us to stick with that divide by because we're working on the divisibility rules. I wouldn't mark it wrong. If you said, well, we can multiply 6 by 6, that's another factor, I'd be okay with that. I'm sticking with divisibility because that's the objectives that we're working on. It's more about what we can divide it into. Either way, it's fine. Madison. Yes. Because on tests we can use the multiplication table, just not calculators. All right, if you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.